JUICED is this university consortium, and the idea here is to accelerate materials discovery all the way up to pilot plant and devices.
So one of the things we're interested in the hub is taking materials that are typically produced on the gram scale and producing them on a kilogram per hour scale. Ways we do this include continuous hydrothermal flow synthesis, freeze drying and continuous rotating tube furnace.
Yeah, so what we've got behind me here is the continuous hydrothermal flow synthesis process. This is a lab scale process and we can make hundreds of samples relatively quickly, and then by making these samples we can screen them to find the one with the best properties. So this might be the best battery material or the best catalyst. Once we've identified the optimum material composition, we can then scale this up using the UCL pilot plant process.
Well, my name is Furio Cora and I'm a professor of computational chemistry here at UCL. And my role in the JUICED consortium is to provide computational chemistry expertise to match the experimental work.
So my research focuses on the discovery of new materials for lithium-ion batteries and capacitors to try and improve the performance of the devices as well as improving the sustainability and environmental friendliness of the compounds used to try and fulfill the growing need of the energy market.
There's two ways in which you can link the simulation of materials with the real experimental side. The first one is to help understand experimental characterization, for instance spectroscopic signature, which are very difficult to characterize. And the second one, once we understand mechanisms in which materials operate, is to use modeling predictively to design new materials which have better properties, which then we can pass to our experimental colleagues to attempt to synthesize.
I work as part of the JUICED Energy Hub, and we're working bridging the gap between academic scale and industrial scale here, so from 20 grams to kilograms, and for that we use a continuous hydrothermal pilot plant that's just behind me, which produces large quantities of slurry which we can then work up and put into battery materials.
Both the pilot plant and this process use something called a confined jet mixer, and the confined jet mixer allows us to mix superheated water at 450 degrees C with the metal salts in a very consistent way to create well-defined nanoparticles.
The JUICED Hub is a really exciting project because it spans materials discovery and the ability to directly scale up using a suite of synthesis apparatus. We think this could be applied to a number of industry sectors, and we're excited about the opportunities that are coming out of the project.
Most universities only ever sit at technology readiness levels 1 to 3 where they're doing fundamental research. But through this capability we can actually go all the way up to higher technology readiness levels that we're typically associated with industry, because we're able to not only discover but also scale up and validate and produce devices as well.